Hello everyone. Today we learn about Thevenin's theorem. So first thing, what is Thevenin's theorem? It is basically a mathematical technique which we can reduce a network to a single voltage source with a series resistor. A linear bilateral network can be converted to a single voltage source that is called VTH or Thevenin's voltage, which is open circuit voltage across the load terminal, and a series resistor which is called RTH, that is Thevenin's resistance, which is the resistance across the load terminal when all sources are replaced, and last one, the load resistor. First thing, when we calculate any branch current or voltage by using Thevenin's theorem, when we calculate VTH, the load resistor is removed. So in step 1, there is 3 steps to calculate a current in or voltage across any load by using Thevenin's theorem. In step 1, first one is calculation of VTH. First point to remember, during calculation of VTH, the load terminal is removed. The load terminal is removed by open circuit, and the open circuit voltage is measured across the load. In step 1, we have to do 2 things. First, we have to remove the load terminal and we have to measure the voltage across the load terminal, which is called open circuit voltage, or you can say VTH. In step number 2, we have to calculate RTH. During calculation of RTH, same load terminal is removed, and if there is sources, then the sources are replaced by a short circuit or open circuit. If there is voltage source present in the network, during calculation of RTH, we have to short circuit the voltage source, and if there is a current source present, then it is open circuit. Current source is open circuit. Then, in third step, we have to calculate IL by rearranging the circuit again. In step 3, construction of Thevenin's network. During construction of Thevenin's network, first we have to place our calculated VTH value or Thevenin's voltage. Next, we have to connect the RTH in series with VTH, and the load will be in series with RTH and VTH. For calculation of IL, we have to apply a formula as usual, Ohm's law. That is, IL will be total voltage of the circuit is VTH divided by total resistance is RTH plus RL. Or we can calculate VL across here by IL into RTH. IL into RL. Let's do a example for better understanding. So I am going to solve this network. The main aim is to calculate IL here. For calculation of IL, I am going to put Thevenin's theorem. First, in step number 1, we have to calculate VTH. As said before, for calculation VTH, this load network is removed. First, this load network removed or open circuited, and VTH is measured across these 2 points. I am taking this point as A and B. So I am reconstructing the circuit. This is my 10 volt voltage source. This is my 5 ohm resistance. This is my 3 ohm resistance. So voltage is calculated across these 2 terminals, A and B. So we have to measure VTH across A and B. This is my 10 volt voltage source. So we can apply this circuit, or we can calculate by 3 methods. Same thing as said before, by nodal analysis. Second one, mesh analysis. Third one, by using Ohm's law. So I am going for second method, that is mesh analysis, because I have already explained node analysis in previous in superposition theorem. So I have to apply, since it is an open circuit, there is no loop, there is only one loop. So I am taking current I here. So if I apply KVL or mesh analysis here, then first thing in KVL we have to go for polarity determination. If the current is flowing in clockwise direction, the polarity will be plus and minus. This will be plus and minus. Since there is no current in 5 ohm resistance, the current flowing is I1. So I, and in 4 ohm same current will be flow. So it is a only single mesh. So if I apply this plus and minus, so first thing, there is a technique that if you take first polarity of any element, then you have to take first polarity of every element. So first I am taking minus 10 volt. This is the first polarity. If I am going from this point, this is my first polarity, that is minus 10 volt plus. Voltage across this 5 ohm resistor will be, I am going to take first polarity, so 5 into I1 or I, 5I plus this is my 4I, which is equals to 0. I got a new KVL. So 5I plus 4I equal to 9I. So I am taking 10 volt from here to here, that is equal to 10. So I will be 10 by 9 ampere. So the current flowing through this resistor is 10 by 9 ampere. So the voltage across this resistor is equal to voltage across these 2 terminals, since it is open circuited. So voltage across 4 ohm will be 4 into I. So my voltage will be, 4 ohm, 4 into I, that is 4 into 10 by 9 or 40 by 9. In decimal, we have to transfer to decimal. 40 divided by 9 equal to 4.44 ampere. Sorry, 4.44 volt. So my VTH is 4.44 volt. Second, in step number 2, we have to calculate TH. For calculation of TH, first thing we have to remove the sources. As I told before, this voltage source will be short circuited and the load terminal will be open. So I am short circuiting the voltage source. Then this resistor will be my 5 ohm resistor, this is my 3 ohm resistor, this is 4 ohm resistor, this point A and point B. So I have to calculate resistance, or I have to measure resistance from here, A and B point. So for looking from this A and B point, so 3 ohm is series, 5.4 ohm with 5.4 ohm are parallel, and 3 ohm is series with both. So my RTH will be 3 ohm plus 5 ohm parallel 4 ohm. Okay. So 3 plus. So I have told before that if there is two resistors parallel, then the net resistance will be R1 into R2 divided by R1 plus R2. Not to go for conventional things, that is 1 by R1 plus 1 by R2. Directly put into R1, that is 5 into 4 by 5 plus 4, that is 3 plus 20 by 9, or you can say 9 into 3, 27 plus 20 divided by 9, which is 47 by 9. Normal calculation, we can 47 by 9 equal to 5.22 ohm. Calculation of RTH is done. So I am repeating these steps. First step is to remove the voltage source as a short circuited and open the load resistance, and to calculate RTH across A and B point. So here 3 ohm is series with both parallel 5 and 4 ohm, because 5.4 ohm is parallel, and in this configuration 3 ohm is series with them. So next go for step number 3, which is construction of RTH circuit, Thevenin circuit. In step number 3, we have to construct Thevenin's equivalent circuit. Thevenin's okay. In Thevenin's equivalent circuit construction, first we have to put VTH here, and then RTH here, then RL here. Both RTH and RL will be in series with the Thevenin's voltage. So VTH is my 4.44 volt, and RTH is my 5.22 ohm, and RL is my 2 ohm. So my target is to calculate load current, that is IL. So before I am told that IL will be VTH by RTH plus RL. So VTH will be 4.44 volt, and RTH is my 5.22 ohm, and RL is 2 ohm. So which is equal to 4.44 divided by 7.22, which is equal to, I have calculated before, 0.61 ampere. So finally we have calculated load current across through the 2 ohm resistor by applying Thevenin's theorem. So I am repeating the steps. In first step, I have calculated VTH here by applying mesh analysis, or by simply Kirchhoff's voltage law. In calculation of VTH, I have open circuited the load terminal, and other elements remain same, and measured the VTH across A and B. In step number 2, I have calculated RTH. In calculation of RTH, the voltage source is short circuited, and RTH is measured across A and B by removing the load terminal. In step number 3, I have constructed the Thevenin's equivalent circuit by just putting the VTH, RTH and RL in series. Then I have calculated load current, that is IL, by applying simple Ohm's law, VTH by RTH plus RL. VTH by RTH plus RL. That's it.